Okay, so I'm going to start by talking a little bit about the Zooniverse and specifically what we actually get back when people uh, transcribe pages on the Zooniverse. And so once you've transcribed a page on the Zooniverse, you know, the sort of the action is you put a box around a plate number and type in what that plate number is, or if the page is blank, you say it's blank. Every interaction is logged, and we get basically back this giant spreadsheet that's maybe 100,000 individual rows of data with every interaction that happens on the Zooniverse. And so the Zooniverse is really about, like, their sort of ethos is give you as much data as possible because we don't know what the project developer is going to want, and then you can work through it. What we have to do is find a way to take out of this giant spreadsheet the data that we actually want, which is just the plate numbers matched up to the individual pages in the notebooks so that we can enhance those records later on and connect it to the DASH project, which is the project that actually digitizes the glass plates. And so if I zoom in on just a single cell from this spreadsheet, it gives us all this information about both the size of the boxes that you're drawing and where they are on the page. And so far, we're not using that data. And so this is something that came up last time. A lot of people maybe expect that we are using that somehow. What we found when we did a beta test of the Zooniverse project is that if we just asked people to basically free type all the plate numbers that they see on a page, it was very easy to lose your place on the page and miss plate numbers. And so we found that we got much better accuracy if we asked people to draw a box and write an individual plate number and then draw another box. And so we use that Zooniverse tool. So at this point, we're not using, again, sort of this pixel information about where the boxes are. We're just taking out the plate numbers out of your answers. And so that's what I highlighted here in green as an individual plate number. And the way that we break apart this spreadsheet is with a number of scripts written in the computer language Python. And if you are interested in sort of data or text analysis, Python is a very useful language to learn, partly because there's been a lot of packages and things written for it to do this kind of work. So you don't have to reinvent the wheel because there's a lot of neat things out there that help you do this kind of textual analysis and break apart a big text file, which is basically what we get back from the Zooniverse. And we also went out and tried to find scripts that were already written that would do what we want. And so one of those scripts that was really helpful that you're seeing here was written for another Zooniverse project called the Notes from Nature project. And in that project, instead of astronomy data, they were looking at like botanical records of like flowers and things like that. But we found that a lot of what they had already done could be applied to our project. And so we're using that to do the matching. So basically we have 7 volunteers look at every page, and we need a way to match up those records. And so that's sort of that's really the power of this script. But to make it work with our project, we do need a workflow where we clean up the data to make it so that it sort of fits with what they'd already written. And so we use a number of Python scripts, some that we wrote and some that Zooniverse created. And in the end, we end up with 2 CSV files, one with what we call the clean data, the things that we're pretty confident we know these are the plate numbers that belong to this page, and the messy data, the ones where we don't know if this is actually a plate number because the computer can't tell what are plate numbers. It just is giving a best guess based on that matching script. So we might have to return to some of those and either do a manual intervention or write some more computer scripts to clean them up further. So I just want to give a couple examples so you can understand sort of what the computer script sees. And so if in a lot of cases, it's really simple like this, you have 7 people look at a page and they all say, there are no plate numbers here. So it says all 7 records are blank. And that's perfect agreement. We are very confident and then there are no plate numbers on that page. We also get a lot of times where maybe 6 people agreed that there were no plate numbers, but one person put something different. And so in this case, we're going to categorize all of these kinds of disagreements where maybe there's one outlier as messy data, because we're thinking that occasionally someone might see a plate number that no one else sees, and we might want to return to this at a later date. But in most cases, it's things like this, where someone misidentified something that looked like a plate number as a plate number, which is the case here. And then this is where it gets a little bit more complicated, but is also really common. If you've been transcribing the PHaEDRA notebooks, you'll see lots of pages have just tons of plate numbers. And the problem with that is that it's very easy to make small mistakes, either miss a plate number or because of handwriting, misidentify a plate number. And so for that, we need something called fuzzy matching, where it looks at places where most of the 7 volunteers agreed, but it doesn't necessarily need perfect agreement to come to a best answer. And so as an example, here's a page where we have a best answer, but there wasn't actually perfect agreement. There was 5 people who identified AM 600. There was 1 person who didn't identify that plate number at all. And then there was 1 person who, because most of the other plate numbers on that page were AC series, said AC 600. And so this is a case where, because 5 people all thought AM 600, the algorithm that we're using said that is the best guess, and that's what it would write to our output file. So hopefully that makes some sense, and it's the way that we take your data. And the reason we have 7 people is because if we just had 2 people, this kind of analysis wouldn't be possible. The computer needs a little bit more confirmation that a number of people are all in agreement for it to make these kinds of guesses. Okay, I'm going to pass it over to Katie.
There we go. So I'm going to talk about how we went from having 2,500 handwritten notebooks stored in 135 boxes to verified metadata, digital scans, and PDFs that can be viewed by anyone in the world. It started in the 1970s when Joseph Timko from Columbia University in New York visited the observatory. He worked with Dr. Martha Lillard, who was the curator of the glass plate collection at the time, to meticulously catalog the notebooks by hand. He produced a typed catalog using a typewriter of these volumes in 1975. And this is kind of a sample page from that catalog. Each line represents a single notebook. You have information such as the title, the year it was written, and the call number, that kind of KG number that Nico had as a example of a non-plate number. Then in the 1990s, someone actually converted that typed catalog into an Excel spreadsheet. So they retyped it all up into a computer. They also re-examined the notebooks at that time to capture additional information about each notebook. And this is a printout of that Excel spreadsheet with a note from who we believe is the person who did that updating work. I'm sure it was a huge relief for them when they finally finished such a massive project. And you know, their efforts were not in vain. Just a few years ago, we actually used this spreadsheet and took it to the next step, converting it into a full database. This project was undertaken by one of our library assistants, Dan Guaracino, in 2017. He also built a full user interface to make the information easier for us to browse and update the notebooks. It took about a year to build the entire system, and it's a database that we use not only to collect metadata for each volume, but also so we can keep track of the project workflow as we're contemplating the organization that would be required for digitizing the entire collection. So here's kind of an example of that workflow tracking. And actually the database came online in October of 2017, but we had kept notes for the boxes and the volumes that we had already started the process. That's why you see a bunch here at October, and these dates in July in the notes field here. So in the next few slides, I'm going to have some images of the process that each volume goes through. First, we requested the boxes from the Harvard depository, which is where they're kept in a temperature and humidity controlled environment to increase their longevity. And they wait here in the library offices to be processed. We usually got about 8 boxes at a time. Over the course of the next few weeks, our library assistants, such as Sam, would go through each book and verify the metadata that we already had in our database and update or add additional information so that the records that we had would be the most accurate and complete as possible. They would also flag things that were inserted into the volumes to make sure they wouldn't be missed during the digitization project. And this is a drawing by Sergei Kapashkin, who was Cecilia Payne-Kapashkin's husband. And Sam will actually show a few more neat examples of these inserted items later on in the presentation. So after all the volumes were looked at and all the metadata was verified, we sent these boxes onto the Harvard Library Imaging Services. Here, the notebooks were carefully photographed using specialized equipment to capture high quality and detailed images. So you can see they have those PHaEDRA boxes in the foreground here, and they each have one of these books laid out in their, imaging platform. So these images are then processed and organized by imaging services, and this shows an overview of many pages scanned from a particular volume. After imaging services digitized all 8 boxes, they would return those boxes back to Wolbach Library, along with an external hard drive containing all the images from that batch. We then transferred the hard drive to ADS, the Astrophysics data system. And actually, I would usually hand it off directly to Edwin, who is on this call. ADS is the premier place to find astronomical literature, and they also provide other technical services, including, hosting our images. They also generated PDFs so that these volumes can be freely shared online. And there's a link there on the side to the finding aid for Project PHaEDRA, where you can get links to each individual volume. So the next step, once we had all those images digitized and online hosted somewhere, was to get these images, to get each volume added to the transcription center so that people could go through and, write in a machine readable way what was written on each volume. So this screenshot shows the project import interface that the transcription center has, but it's actually meant to work only with images stored on the internal Smithsonian image archives, which, well, we're not using because ADS is hosting our images. So instead of using this interface, I wrote a Python script that exports information from our PHaEDRA database and generates a CSV file for each notebook. And the CSV files look like this. So it's pretty simple. There's the title of the volume at the top, and it lists the URL for each page image below that. So I would collect a batch of about 50 or so of these together into a zip file, and then email them to Caitlin Haynes, who is the Smithsonian Transcription Center Program Coordinator. And then she would work with developers at the Transcription Center to have our projects manually added to their databases. So once they're added to the database, we can see them in the back end of the Transcription Center. And so this is 3 notebooks that are waiting to be transcribed. They aren't currently online yet because we have so many waiting to go, and they haven't been transcribed. But many of them actually have been transcribed so far. Once a volume is transcribed and reviewed by volunteers, we approve that transcription. While most pages can be accepted as is, sometimes we'll see missing information or other small errors, and in those cases, we send the pages back to the volunteers. Otherwise, we approve the transcription, and then the next step, which is still something that we're kind of in progress and working on the volumes that have been transcribed, is to send those transcription files over to ADS so that they can add the full text into their system, and that allows it to be full text searched in the Astrophysics data system. All right, now I'm going to pass it on to Sam, who will be talking more about PHaEDRA and Zooniverse.
Thank you. So I'm just going to, share my screen now. Great. So I'm just going to be talking a little bit about some of the really interesting things that volunteers have pointed out to us, specifically on Zooniverse, because Zooniverse has that talk board feature, unlike the Smithsonian Transcription Center. So it's able to, identify and different things for us. And, you know, the volunteers have been really great with asking questions and pointing things out to us. And so over the past year, which is how long our Zooniverse project has been going on, I've kind of been able to collect some of these random things that have been found. And for example, these two images, you'd think they'd be associated with the glass plates collection and Dash or something like that, but these have been found in our notebooks, so it's always a pleasant surprise to see some glass plate, you know, recreations in the notebooks. But so I'm just going to point out some things that have been found and identified. So we're used to looking at kind of, if you've seen the notebooks or transcribed on one of our two projects, you're used to seeing kind of like these rows and rows of data, and sometimes and those calculations are represented in graph format. A Dorrit Hofflet notebook on the left and a Henrietta Swope on the right. And just to point this out to folks, the PHaEDRA number at the bottom points to our finding aid. So if that's just like a citation of where these images come from. So sometimes, you know, these are two examples of comets that have been identified in the notebooks, and over time, names of objects change as we learn more about them. And so what was originally identified on the left in 1899 is just called Coddington Comet. The name has changed a bit, and the same thing with Comet Brooks on the right. So it does definitely highlight that history of science element. Same thing here with the Ring Nebula, which is discussed in the notebook page on the left in 1909, and on the right we have you know, such a clear image of that, and so it really shows the connection between past and present astronomy. And so Annie Jump Cannon is kind of well known for her work on spectra. And so these are two examples. The right is from a Hofflet notebook and the left is from a Cannon notebook. But these are two examples of spectra as discussed in the notebooks. And so the computers and astronomers did a lot of work in this area. And this is like one of my personal favorite topics, I guess, is like some of the kind of random things that have been found in the notebooks, because I think it really shares a lot about the lives of these people. And so here, like, there's a 4-leaf clover, in the middle is a Christmas card, right? So I think it also shows it tells a really asynchronous story of a really asynchronous timeline of these notebooks sometimes, because sometimes things would be added in decades later, you know, different announcement cards, notes to different astronomers, that sort of thing. And so I think it's really neat to find those random things in there. This one is an example of they're basically discussing like a new variable, you know, some of the possibilities, like those types of things. And then at the bottom, it says not to be announced at present, which I think is really neat, because they're trying to keep it quiet for now, you know, not sure, you know, but I think that's an interesting find. And of course, some star charts. There are a lot of star charts in the notebooks, a lot of drawings, some of them are really complex. Another example of a star chart graph, and on the right is a more modern example. And this is an example, a recent find that was pointed out on Zooniverse of a roseau. And the image is cut off because I couldn't like fit the whole image on the screen, but there's a note on the bottom that says, as two plates are adjusted, center may be slightly off, hold head a little to left of center to correct this. So it's kind of like a guide for the user, a personal guide from Ida Woods on how to use this tool. And of course, we have another example of objects and kind of glass plate recreations in the notebooks with the Large Magellanic Cloud. And also one of my favorites, Search for Giants and Dwarfs. This sounds very much like a sci-fi fantasy book to me, and so this is one of my personal favorite notes in the notebooks. And of course, lastly, I just want to highlight some of the really great work that our volunteers are doing, some of the calculations that they've been doing, and we certainly don't ask this extra research to be done of our volunteers. We're happy with any level of, of work that's done, but we're really thankful for our volunteers who, take that extra step with their calculations of Julian dates to, really solve those questions and stuff like that. And so, and some, volunteers who use Dash and all the different resources that there are to do their own research and really connect with these materials. So we're really grateful to them for that. So now we can kind of take any questions, or if anyone wants to bring up a discussion point, we're happy to answer any questions about the presentation or about, PHaEDRA in general.